Hey, so here what we're doing is we're looking at a derivative of a linear over a quadratic. And these, I'm pretty sure, can be kind of done like this in every instance. What we want to first do is exploit the natural logarithm rule, okay? And so what we want to is we want to sort of rewrite this numerator such that inside of it, you find the derivative of the denominator, right? So first I'll take the derivative of its denominator, and it's 2x plus 2. All right, so the derivative of the denominator is 2x plus 2. So what I do is then I write that here, and I say, okay, now we need to somehow make 2x plus 2, turn it into 4x minus 1. So in order to do that, I need to multiply it by a 2. All right, so this is what this does. That way I've got 4x plus 4. But I've got a 4 now as my constant term, but I need a 1, negative 1, and so I'll subtract 5. So remember, start by taking your derivative, writing it down, and then multiplying a constant in to take care of the coefficient here. And then you can add or subtract any number that you want here in order to get this constant term. Now, basically what we've done here is we've said, all right, 4x minus 1 is equal to this thing. And this thing has the derivative of the denominator in it. So remember, you start with this derivative as you're starting to, thinking about figuring all this out. Now, this gets rewritten up here, okay? And now, basically, what we can do is we can separate all this stuff out. This 2 can be pulled out, and these two terms can be separated into two completely different integrals. The 5 can be left here. And now this is actually a very easy integral because it's a derivative over its antiderivative. And so there's the rule that says the integral of g of prime of x over g of x is equal to the natural log of g of x plus c, right? And so there it is. We just convert this over to the natural log of the denominator. All right. Now, this one here, this one's an easy one as well. You're going to have to complete the square and then apply the inverse tangent rule, right? And this one always requires some kind of complete the square in either inverse tangent or like inverse sine or something along those lines, depending on what you have here, right? Okay. So when I complete the square, remember what we do is we take this middle term, we cut it in half, okay, and then we square it. So I take that middle term, it's 2, cut in half is 1. Now I square it, okay? Then I add and I subtract that number, okay? Now this section here, x squared plus 2x plus 1, can be converted into this perfect square, okay? Because this is a perfect square trinomial. Now, negative 3 plus 3 is just 2, right? Sorry, negative 1 plus 3 is just 2. Then we have to rewrite this, since this is the sum here. I'm going to rewrite this as the sum of two things squared. The sum of two things squared. So this is x plus 1 squared. That one's already. 2 squared. I'm going to have to rewrite this as the square root of 2 squared. Okay. Why am I doing that? So that way I can exploit this rule down here, which kind of doesn't look like this, but oftentimes it looks like this. 1 over, right, some sort of function squared plus a constant squared. You can use the inverse tangent rule. So that's what I've got. So I've rewritten this denominator down here. And there, if you look at that, it's you take your square, your this thing, and it goes right there. Then your square root of 2 goes there, and bang, you've got yourself your inverse tangent rule. Don't forget the 5 should stick around out there in the front. And there you have it, right? So we've got how to do the integral of a linear over a quadratic. And more or less, I think pretty much every one can be done in this way. There might be a few exceptions, but not that I can think of right now.